So we're on 7-2 today, solving exponential equations and inequalities. So like I said, on Friday, with the first section, we graphed exponential functions. So we graphed exponential growth. So look up here. Exponential growth goes this way, right? It goes up really high really quickly. And exponential decay, that's hard to do backwards, would go this way, down really fast, really quickly, okay? So exponential growth, for example, would be like typically, I don't know, bacteria. I think I heard bamboo grows exponentially, I think. Exponential decay would be, I think a lot of people use an example of the stock market crash. That went down really fast, really quickly, right? So that's what we did on Friday. We just graphed some graphs. It wasn't like too scary, okay? The front of your notes from Friday are great to know, but they're a little bit intimidating. So all we really have to do is do a t-table and plug and chug. So the front of your notes from Friday were to try to help you do that faster with the tips and tricks. But even I don't graph exponential functions, remembering the 1 over b and the 1 over 1 comma b. Like even I don't do that. I mean, you can, it's great, but you don't have to. Okay? So if you understood Friday, great. If you didn't, that's okay too. We'll come back to it. All right? So for today, we're going to be solving them. We're not graphing them, okay? So when we solve these things, if I have 10 to the x equals 4, okay? Something like that. You don't have to write that down. You totally can, though. I'm just trying to tell you where we're going. I can't solve with an exponent as a variable, or a variable as an exponent. It's the same thing. I can't solve with x up here. It needs to come down, basically. I can't do that. So that's why these rules over the next sections exist, okay? So we can bring that x down, basically. So if I have b to the x equals b to the y, these are the same base. These b's are called bases, okay? Because they're the same, basically you can kind of think of it as they cross off because then x is equal to y. So if b to the x is equal to b to the y, then that means that the exponents were equal, x is equal to y. So same thing here. You see that these are the same base. I have a b and a b. So if I have a 10 and a 10, I can do it. If I have a 10 and a 2, I can't. It's not the same thing. Do you get what I'm saying there? Okay. If the base is the same, then this is b to the x is greater than b to the y, if and only if x is greater than y. So again, you can kind of think of it as cross off the bases and the exponents are still there, is kind of what we're doing, okay? If b to the x is less than b to the y, if and only if x is less than y. We will come back to this probably tomorrow, but because of the delay, I don't think we're going to have time to cover that today. So we'll come back to that later, all right? So solve each equation. Our goal is to get the bases the same. That's really the only way that we know today. Eventually we'll learn some more options though, okay? So I typed these up so you have more space. So if I can make both of those a 3 or both of them a 27, that's what I want. So I don't want to actually tell you what to do yet. I want us to kind of think through it and maybe be wrong, and I'll show you why it's wrong. Sometimes we learn better that way, okay? So in your mind, I want you to think, do I want to make both of those a 3 or do I want to make both of those a 27? Just pick one. It's okay. All right, raise your hand if you think 3, okay? Raise your hand if you think 27. All right, so here's why it's 3, okay? If you were to make this 27, I know that if I take this to the what power, it would be 27? 3, right? If I cube this, it's 27, right? So you guys weren't totally wrong thinking the 27. You could do that. But if I cube this side, what do I have to do to this side? Cube it again. So it's not really 27 anymore. Does that make sense? But I can make this 3 to the what? 3rd. Did I really change the problem, or did I just change the way 27 is looking? Do you see what I'm saying? So it's kind of like when you go to the lunch room and you have a dollar bill and you give it to them and they give you 4 quarters back because you want to go get a pop or something, right? You still have a dollar. It just looks different. Does that make sense to you? Okay, so that's what we're going to do, because if we had done it the other way, we'd actually change the problem. It's no longer equal. It's no longer balanced. So your goal typically is to make it the smaller number. I don't want to say that's like a rule, but that's typically what I would do. So I'm going to make this 27 a 3 to the 3rd, because I didn't really cube anything. 3 to the 3rd is the same as 27. Do you guys get what I'm saying there? Okay, I still have 3 to the 5x. And I still have this 2x minus 4. Everything else is the same. I haven't actually changed the problem. I just kind of changed the way it looks. Okay? So whenever you have a power to a power, what do you do with those? No. Multiply, right? I'm going to multiply. So this is 3 to the what? 6x minus 12. Very good. Distributive property, right? Is that okay? Okay. Do I now have the same base? Are they both a base of a 3? Yeah. So essentially, they don't actually cross off, but in my mind, that's what I do. Okay. So the exponents are now equal. 5x is equal to 6x minus 12. Is that okay? And now it's super easy. That's what we hope for in Algebra 2. The first 2 steps are new. We have to kind of talk about it. And after that, everything should be old and easy for you. So go ahead and solve for x, please. And what do you get? 12. Anybody not getting 12 and need me to work it out for you? Are you sure? Okay, take your time. You can check it. Don't have to. It's not a rule. We don't have to, especially today since we don't have time. But if I were to check it and plug the 12 back into the original equation, the left side would equal the right side. If you were to actually use your calculator and see what it was. Okay? Anybody confused? All right. Next question. What do I want both of those bases to be if possible? 49 or 7? 7, okay? Is this 7 to the something? Can I rewrite 49 as 7 to the something? 7 squared to the second, right? This is the same as 7 to the second. Nothing else has changed. I'm just going to write everything else in, but 7 squared is the same as 49. Is that okay? So you can kind of do this any way you want to. The first way I showed you was the super proper way. However, on this question, I'm going to do it a little bit differently. I'm going to go ahead and cross off the 7s now because I know that eventually they're going to essentially go away. And I'm going to write it this way. 2 parentheses x plus 5 because I know a power to a power gets multiplied, and then just the 8x minus 6. The reason I'm showing you this way is because a lot of people forget to distribute that 2, and the 7s just kind of intimidate them. That's just kind of in the way. So if you want to do it this way instead, you can. If you find that you get it more right more of the time, then do this instead. Either way, you're still fine. So we end up with what? 2x plus 10 equals 8x minus 6. Have you guys already solved it while I was talking? What'd you get? Reduce always, right? Take your time. You guys can totally use a calculator, but typically I don't. I think it's more work. So I'm going to subtract the 2x and get the 6x. I'm going to add the 6 and get 16. When I divide by 6, 8 over 6 reduces to, 16 over 6 reduces to 8 over 3. I gave you half the answer. Sorry. I'm always 5 steps ahead. Is that okay? So that's why I kind of don't use a calculator. You totally can, but I saw you guys trying to change it back to a fraction and stuff, and it probably took you longer than if you had just done it that way. So you do what you're comfortable with. As long as you get the answer right, I don't really care. Is everybody okay? Not terribly scary? Okay? Good. All right. Do I want to make both a 9 or both a 27 if I can? That sounds great. Can you make 9 something to a 27? No, right? So that rule doesn't always work is what I was trying to say earlier, okay? If it had worked, great. But 9 squared is my first option, and 9 squared is not ever going to give me a 27. It's 81. Do you get that? So we're going to have to change both of them to a base of something. Hopefully they can both be the same base. So I usually start with my 2's. Okay, well 2 to the something's never going to give me a 9, so stop there. Then I go to my 3's. Okay, well that would be 3 squared. That would be 3 cubed. So the 3's are going to work out. Do you get that? If it hadn't, then I'd try 4, then I'd try, right? So this is really 3 squared, and this is really 3 cubed. If you don't believe me, punch in 3 to the third, and it's 27, okay? I still have my 3c plus 1, and I still have my 3c minus 1. Do you guys want me to get rid of the bases right now? Was that easier for you? Or do you want me to go ahead and distribute now? Okay, either way, you pick one. I find that most people kind of do better if they rewrite it this way. But you do whatever gets you the right answer. I don't care how you do it, okay? So I'm going to go ahead and now I'm going to distribute. And I get what? 6c plus 2 equals 9c minus 3. Is everybody okay where we are? That's the new stuff. That's it. So solve for c. Take your time. Always reduce if it's a fraction. What'd you get? 5/3. Anybody not get 5/3 and need me to show you the math in between? I'm happy to do it. Just let me know. Are you sure? So again, if we had time, if we weren't sure it was right and we had time on a test or a quiz to go back and check it, I'd plug it back into the original and see if the left side equaled the right side, but it's not a rule like it is sometimes, okay? All right, we're going to skip these for now. Let's go ahead and go to number 25 on the back of your notes. Okay, idea's the same. What's the only thing that's different? It's an inequality, big deal, right? Same thing, okay? So are these the same base? Not yet. Can they be? Yeah, 10 to the what gives you 1,000. If you're not sure, we know it's not 10 squared, that's 100, right? Take 10 cubed on your calculator, let's see if that works. Is that 1,000? Yeah, 10 to the third, 10 cubed, not cubed root, okay? 10 to the third is 1,000. So that worked out nicely, right? I'm going to go ahead and get rid of my 10s, okay? The actual property just says that the exponent is greater than the exponent. We're not actually canceling or getting rid of 10s, but visually for me it's easier to cross that off. I don't want you to think mathematically that's what happened though, okay? So we end up with 5b plus 2 is greater than 3. Just like on the notes on the front page, right? On the front page at the top, if it said the left side greater than the right side, it stays left side greater than the right side. Is that okay? So we're going to subtract the 2. So 5b is greater than 1. Divide by the 5. b is greater than 1/5. Have I lost anybody? Interval notation. b is greater than 1/5. All right? This is technically an Algebra 1 answer, so interval notation is more like an Algebra 2 pre-calc answer. Okay? So we're going to say 1/5. That's not 1/5. 1/5 comma infinity, because they said greater than. That part I think you guys remember. Okay? What does infinity always get? Parentheses. What's this 1/5 going to get? Parentheses or brackets? Parentheses. If there's a hard straight line, give it a hard straight line. If there's not, don't. Okay? Did I make an interval notation review video, like a 5-minute one? Has anyone ever looked or found that? I'll try to. I can't today. I got Good News Club, but I will try to make like just a 5-minute video, and you guys will be fine. If we had wind today, I'd tell you just to come in, but we don't, okay? So I won't make it tonight, so if you really feel like that's hard for you, you could come and win tomorrow. Give me 5 minutes, and you'll know what you're doing, and I'll try to make a video sometime soon, okay? Or you could, for extra credit, if you're confident that you did it right. That could be your project. Okay. So that's our final I'm done answer. Anybody confused? Other than maybe interval notation, but that'll come to you, okay? All right, same idea here. For 2 seconds, pretend it's just 27. It's not, right? But pretend it said 27. I need to make these both the same base. There's no way I can make them each other. You get that right? Okay? So this is the same as hopefully what? What base do you think you can make 27? A 3 to the something? And then 81, a 3 to the something, hopefully. So 3 to the what is 27? 3 to the third, right? And then 3 to the what is 81? Fourth? Anybody struggling with how to figure that out? Even I don't know ahead of time what I'm going to pick. I just kind of start with numbers I think might work. So I was like, yeah, I know 3 cubed. I don't know. Even I didn't know 3 to the fourth was 81. I don't remember that one all the time. I use my calculator, and I'm hoping that 3 to the something is 81. Do you guys get that? However, this isn't 27. It's 1 over 27. These aren't the same base. 1 over 3 is not the same as 3. Would you rather have $3 or a third of a dollar? They're not the same, right? So how am I going to make them the same? Not on this, because we're not actually, the exponent is the variable right now, so if it wasn't, we could do that, but we can't do that here. It wouldn't help us. Couldn't I move this up? And then it would be 3 to the negative 3. Isn't that still a base of a big 3? Right? If I move this up, 3 to the negative 3, don't they both have a base of 3? Do you guys get that? Okay, I could have made this a fraction instead, but most people kind of don't really like fractions, so I just went ahead and moved it up, because when you have an exponent in the denominator, if you move it to the numerator, it's going to change to it's going to change to the opposite. If we had a positive, it's now a negative. Is that okay? So my 3's, I'm good. They match now. Okay? So I have negative 3 parentheses 2d minus 2 less than or equal to 4 parentheses d plus 4. Is that okay? Okay? Distribute, what do we get? Negative 6d plus 6, maybe, less than or equal to 4d plus 16. Everybody try to solve that from there without me. If you can't solve it without me, tell me and I'll do it for you, but I want you to try. When did I say we get off? 43? Okay. 10 minutes, we can do this. What that means is I speed up. Okay, what'd you get? Yep, d is greater than or equal to negative 1, or maybe you got negative 1 less than or equal to d. Those are the same. Did you at least get one of these? Is this okay? Okay. Typically, these are both equivalent answers. Neither one's more right than the other one, okay? But most of you do better if you write it this way, because interval notation, I think, is a little bit easier to go off of this one when the letter's on the left than the other way. Either one's right, though, okay? So if it's greater than or equal to negative 1, that means I start with my negative 1, and I'm going to go to infinity, because greater than a number is to the right of the number line. That's positive infinity, okay? What's infinity always get? Parentheses. This has a straight hard line, so a straight hard line, bracket. Is that okay? We good? Okay. On this one, go with your gut. What do you think the bases are going to be eventually? 5s, right? 5s, okay? So I'm going to go ahead and make this 5 to the negative 1, still to the x minus 5. Is everybody okay with what I did? I moved it to the top so the exponent changed signs, okay? And this is obviously 5 squared, right? Anybody confused there? Okay. I'm going to go ahead and essentially set the exponents equal. So negative 1 parentheses x minus 5 equals 2 parentheses 3x plus 2. Distribute negative x plus 5 equals 6x plus 4. Take your time and find x for me, please. And again, I always skip in here. If you need me not to do that, just say something and I'll show the work. What'd you end up with? Anybody think you got that one? Yeah, 1 over 7. It's an equal sign, so we don't have to worry about interval notation. Anybody get it wrong and need me to do it? Okay. Does anyone still need it? Okay. On this next one, some people are still writing. On 37, last one we're going to cover today. That looks a little scary, right? None of those are going to be the other one, okay? So what you have to do is just kind of go with your gut. Look on the left side. Just shout it out. When you see a 25, what are you going to try? 5 squared probably? Maybe, I don't know, right? You see there's 81, maybe what's that? A 3 or a 9? Not sure yet, right? So over here, I'm hoping one of these is a 5 to the something and one of these is a 3 or a 9 to the something. Okay? So I'm gonna go with my gut. I feel like this is probably 5 squared and this is probably 9 squared. Because if these match, it's easier, okay? So 5 to the third is what? 125. Okay, well that worked out nicely. So if this is 5 to the third, I probably need 9 to the third. So let's check that. What's 9 to the third? 729. So pause and look up here when you can, okay? It was pretty easy to guess that this was probably 5 squared, okay? Bless you. However, this could have been 3 to the 4 or this could have been 9 to the 2. Do you guys understand either of those technically are right? If this is something to the second power, these need to match or else this next step is going to be hard, okay? Plus, this I'm sure isn't 3 to the something anyway. So it had to end up being, oh, excuse me, this probably isn't 3 to the something, so it was 9 cubed instead. And see how these cubes match up? Okay? So if it's 5 squared over 9 squared, it's the same as 5 over 9 squared. So instead of writing a 2 and a 2, I'm going to write the 2 one time. So pause. Don't look at this right now. If this is all I had, and I didn't have that extra, I could rewrite it as that. These are the same. Is that okay? Okay. It's confusing for me to have it that way. So I'm going to write 5 over 9 squared. You could do it like that, I guess, if you want. And 9 over 3, no, excuse me, 9 over 5, sorry, cubed. If they don't match, you can't do it anyway. They need to match. The bases need to match and the exponents need to match. I said that in a way that maybe didn't make sense. These eventually need to match, the 5 over 9 and the 9 over 5. We'll deal with that in a second. But if these weren't both 2's and these weren't both 3's, you kind of can't do what we just did. Okay? These don't match yet, but they're pretty darn close. What do I want to do? Flip one of them. Yeah, and then that makes the exponent negative. Very good. Yeah, that's a property. Which one do you guys want? Do you want 5/9 or do you want 9/5? I heard 5/9, so I'm going to keep the 5/9. It doesn't matter, obviously. Okay? This is now 5/9 to the negative 3. Negative 3x plus 1. That is a property from a long time ago. If you flip the fraction, the exponent becomes the opposite, so probably negative. Do they match now? Yeah, 5/9 and 5/9, our bases match. So I have 2x plus 1 equals negative 3, negative 3x plus 1. No matter how confused you were above what I've written right now, everybody can do that. So go ahead and do that. While some people are solving it, if I lost you up here, stop and ask me a question, please. Thank you. We have just enough time. Is that okay? What did you guys get for x? 1. It's an equal sign, not an inequality, so the answer is 1. Ask me a question on any of them. Did I lose you on any question? What do you need help with? Are you sure? Okay. So for your homework tonight, I can't tell you what numbers it is, but you're going to do your assignment. You're going to get the answers from the binder. Skip the ones we didn't do. So if there's a question on the homework that has words in it, skip that. If there's a question on the homework that tells you to write the equation of an exponential function, we didn't do that one, right? So unless it looks like these easy ones, in my opinion, don't do it. Does that make sense? Okay? And then if you didn't finish Friday's assignment, you need to go ahead and go back and finish that too. Anybody confused? Okay, great.